Many factors have affected the development of personal armor throughout human history. Here are the highlights from past to present. In the earliest days, people used animal skins as barriers to injury and attacks. As weaponry advanced, they added wooden and metal shields to their defensive arsenals. The development of armor has run parallel to the development of increasingly effective weaponry on the battlefield, with armorers seeking to create better protection without sacrificing mobility. The first record of body armor in history was found in ancient Sumeria, what is now southern Iraq. The oldest known Western armor is the Dendra panoply, dating from the Mycenaean era around 1400 BC. Mail, also referred to as chainmail, is made of interlocking iron rings. It is believed to have been invented by Celtic people in Europe about 500 BC. In European history, well-known armor types include the mail hauberk of the early medieval age and the full steel plate harness worn by later medieval and Renaissance knights. In the 1500s, Italian and Roman royalty experimented with the idea of bulletproof vests. They built body armor with layers of metal that was meant to deflect bullets. However, metal body armor was largely ineffective against firearms. In the 1800s, softer body armor was developed by the Japanese, who made the armor from silk. These silk garments proved to be quite effective, but also expensive. One of the first examples of commercially sold bulletproof armor was produced by a tailor in Dublin, Ireland in the 1840s. The first official attempt at commissioning body armor was made in 1915 by the British Army Design Committee, in particular, a bomber shield for the use of bomber pilots, who were notoriously underprotected in the air. During the late 1920s through the early 30s, gunmen from criminal gangs in the United States began wearing less expensive vests made from thick layers of cotton padding and cloth. In the early stages of World War II, the United States designed body armor for infantrymen, but most models were too heavy and mobility restricting to be useful in the field, and incompatible with existing required equipment. In the 1960s, new fibers were discovered that made truly bullet-resistant vests possible. In 1971, Kevlar was invented, a synthetic fiber woven into a fabric and layered that by weight has 5 times the tensile strength of steel. These vests could stop the most common lead bullets. According to the International Association of Chiefs of Police, bulletproof vests have saved over 3,000 officers' lives since 1987. Fast forward. Different types of protective equipment have since been widely adopted by modern armed forces all over the world. Modern body armor is generally split into one of 2 categories: soft armor and hard armor. Soft armor is typically made of woven fabrics like Dyneema or Kevlar. Hard armor usually refers to ballistic plates. These hardened plates are designed to defend against rifle threats, in addition to the threats covered by soft armor. Because of the use of ceramic plates for rifle protection, hard armor vests are 5 to 8 times as heavy to wear. The weight and stiffness of rifle armor is a major technical challenge. While ceramic materials have some beneficial properties for ballistics, they have poor fracture toughness. Failure of ceramic plates by cracking must also be controlled. In recent years, advances in material science have opened the door to the idea of a literal bulletproof vest, able to stop handgun and rifle bullets with a soft textile vest without the assistance of additional metal or ceramic plating. Currently, there are a number of methods by which nanomaterials are being implemented into body armor production. In late 2014, researchers began studying and testing graphene as a material for use in body armor. Graphene is manufactured from carbon and is the thinnest, strongest, and most conductive material on the planet. Taking the form of hexagonally arranged atoms, its tensile strength is known to be 200 times greater than steel. But studies from Rice University have revealed it's also 10 times better than steel at dissipating energy, an ability that had previously not been thoroughly explored. Enter Nova Graphene. Nova Graphene has commenced Phase 2 of a contract with the Canadian military to develop 3D printed graphene-enhanced ballistic plates. They are lightweight, with anticipated positive buoyancy, are heat and chemical resistant, and are custom fitted for optimal mobility for all body types. This is especially beneficial for soldiers with larger busts that until now have not been properly accommodated. In fact, they are working towards components like chest plates and helmets, custom printed from 3D body scans of soldiers, ensuring perfect fit and maximum comfort and mobility. Nova graphene plates have demonstrated decreased brittleness and an increased ability to withstand multiple impacts. The global body armor market size is reported at $2.5 billion USD in 2022 and is predicted to grow at a CAGR of 6.6% from now to 2030. For more information on the exciting developments of ballistic advancements, visit novagraphene.com.